We're going to be moving on to 4.2, which is one-step inequalities. And today we're just going to be focusing on that addition-subtraction portion of it. So to start us off, I want to do kind of like a throwback to our last chapter. So these are both equations. I know because they have an equal sign. So it says to solve the following equations. So remember, this is what we just finished. So draw your line, circle your variable, and solve for your x. So go through and solve these two problems now. For the first problem, you should have gotten x equals 9. And for the second problem, you should have gotten x equals 6. So now I want you to think to yourself how I would answer this question. It says, explain how to solve a single-step addition or subtraction equation. So think about how I, the teacher, would answer this question. How would I explain this to somebody? Hopefully you're just thinking of following our steps. So we would draw our line at our equal sign because that tells us that we have a left and a right side. And if we want to move something to the left side, we have to do the inverse operation. We're going to also KCO any addition or any subtraction that we see because that makes it easier for us to see those negative numbers. We would also simplify if we had that. Neither of these problems had any simplifying that we had to do. And then our fourth step is going to be circling our variable. And that tells us what our goal is. So our goal is to get this x alone. From there, we would do the inverse operation on both sides to remove whatever is preventing our x from being alone. Because we want that x to be by itself. And that 8 is not allowing that. And so we have to move that 8 to be able to cross that line. You have to do the inverse operation, so the opposite operation. The operation here is addition, so we're going to add the opposite, which is negative 8. So now we're going to move into inequalities. Inequalities are the exact same thing. So you already know everything. Congrats. So just like before, we're drawing our line, except this time, instead of it being an equal sign, it is a greater than sign. Our goal is still to get x alone. We still have to KCO that subtraction, and we want to move that negative 2 over to the other side. So right now we have x plus negative 2. We want to get rid of the negative 2 by getting it to be 0. To get that negative 2 up to 0, we have to add 2. And whatever we do one side, we got to do the other side. So we're doing it over there as well. That makes that go away and leaves us with just an x on our left side, which is what we wanted. On the right side, we have 4 plus 2, which is 6. And then we're just going to bring that sign straight down. So now I have an equation that says x is greater than 6. So just like how we learned yesterday, I know that I'm going to have an open circle. So this has been simplified. That was my simplifying step. So now I need to graph my circle. And I know I'm going to have an open circle because there's no line underneath my greater than sign. It's not equal to. So it's going to be open. So I'm going to graph that open circle at my positive 6. Now I need to figure out, is this line going to the left or is it going to the right? So I'm going to pick 4 and 8 because those are the numbers to the left and to the right of where I graphed my circle. So my original problem says x, ooh, that was rough. Let me backtrack there. My original problem says x minus 2 should be more than 4. So let's plug in a 4 first. So 4 minus 2 gives me 2. Is 2 greater than 4? No, it's not. So that means that this 8 is going to work out. So let's just double check to prove ourselves. 8 minus 2 is going to give me a 6. 6 is more than 4. So that is a true statement. That checks out. So that tells me that my line is going to go to the true side. So it's going to go this direction. Let's make that bigger. There we go. And then I'm done. You have to graph these problems though. Graphing the problem shows all of the solutions. Like I said yesterday, these types of not equations, inequalities. Inequalities always have infinitely many solutions because I want every single number that's more than 6. And so that arrow is showing me that every single number that's more than 6 is a solution. How about you go ahead and try this problem here, following the steps from our last chapter, because it's the same exact thing. I'm hoping that you get it. So pause and try it out. First thing you should have done was drawn your line, and then you're going to go ahead, KCO that subtraction, and circle your variable. Now we have to move everything from the variable side over to our other side. So I see that that -5 is preventing x from being alone. It's not allowing it. To get rid of that -5, I have to add 5. And I'm going to do that to both sides, if I can write. That makes that go away, and we're left with just an x on the left side there. On the right side, I have 2 plus 5, which is 7. That's a 7, I promise. Now we're just going to bring that inequality straight down. It was a greater than or less than or equal to sign. And there it is. That is our solution. Now we have to graph our solution. So the first thing that we're going to do is draw our circle. And I know this time it's going to be a closed circle because of this or equal to. So I'm going to do that where 7 is, positive 7. So now that I've plotted my circle, I have to figure out which direction my arrow is going to go. So I'm going to look at one number to the left, one number to the right, and I'm going to use my original equation. It's important to use your original equation because if you messed up on all your math right here, then you're going to mess up down here as well. So if you use this original equation and I get 2 true statements, or I get 2 false statements, I know that I did something wrong. You should always get 1 false and 1 true, just like how I did on this last problem. So let's double check ourselves and figure out which direction this arrow is going to go. So I'm plugging in one number to the left, so that's 6. 6 minus 5 is going to give me 1. Is 1 less than or equal to 2? My answer is yes, 1 is less than 2, so that is my true statement. So just to double check, the second statement should be false. So we've got 8 and then minus 5. 8 minus 5 is going to give me a 3. 3 is less than or equal to true is a false statement. So we've got 1 true and 1 false, so we know that we did this correctly. And now that I have that information, I can go ahead and finish up my graph. So I'm going to draw my arrow going that direction because that's the true side. I've got 2 more problems for you to try with decimals. Just graph it the best you can. Since you guys are making your own graphs, you can make it so it is a lot easier to graph decimals by just doing lines for your decimals. So try these 2 problems out and then check your answer with me. Here are the 2 answers. Make sure to double check yourself and then move on to our next part. So I just wanted to go over and reinforce the idea of what solutions are. So I'm going to go ahead and solve this really quick. So I'm going to draw my line. That is a very thick line. And then I'm going to KCO my subtraction. I'm going to circle my variable, and I see that this x is being added by -3. So since that's a -3, I'm going to add 3 to both sides, and that gives me x on the left because that makes that go away. And then on the right, I've got 9 plus 3, which is 12. So x is less than 12, which means any number that is less than 12 is a solution. So this 16 is not less than 12. So this is not a solution. Oops, I got my circle out. So this is not a solution. That 5 is less than 12 is a true statement, so that is a solution. 18 is less than 12. That's not true. So that is not going to be a solution. And then 10 is less than 12 is a true statement, so that is a solution. So think about that as your idea of solutions. I could put any number I wanted into this problem. Instead of having 16, 5, 18, 10, I could have had -275. It doesn't matter what that number is. If you plug it into your inequality and it comes out true, then it's a solution. And remember that there's infinitely many solutions in an inequality problem. That's all I have for you today, so go ahead and get started on your homework. It's going to be in your textbook today, page 134, and then you're doing problems 4 through 18 even. And so that's the list of them there.